All right, we are going to do our review number 2 for our final. This will be our last review before you take your final. So let's just get right into it. Okay, so for numbers 1 through 4, we are asked to find the area of each shape. Okay, so come back into focus. Our first shape in number 1 is a parallelogram, okay, where all sides or opposite sides are parallel to each other. Okay, so the area formula for a parallelogram, kind of like a little slanty rectangle, is base times height. Okay, base times height. So we really just need to identify two things. We need to identify our base and our height. Okay, well, our base is going to be 4.9 centimeters. And then our height is going to be the 2 centimeters. Whenever it gives you that little dotted line, okay, that is going to be the height, how tall it is. Okay, so then we can just plug this into our formula. We have area equals our base, 4.9 centimeters, times our height, 2 centimeters. Okay, we have a decimal, so you'll probably need a calculator. Just grabbing mine. Okay, so we have 4.9 times 2. It's going to give me 9.8. Okay, so we have the area of this is 9.8 because 4.9 times 2. And then centimeters times centimeters is where we get our centimeters squared. And there we go. Okay, let's look at number 2. So we need to find the area of this triangle. Well, let's remind ourselves that the area formula for a triangle is 1/2 times base times height. Okay, so again, we have 1/2, which remember in our calculator is 0.5. Now we just need to identify the base and the height. Okay, well again, my base is 8. My height is by that dotted line, which is 7.4. So now I can just plug this into my formula. So I have area equals 1/2 times my base, 8 miles, times my height, 7.4 miles. Okay, and then I'm just going to punch this into my calculator. 1/2 times 8 times 7.4. Remember that 1/2 is 0.5 in your calculator, so 0.5 times 8 times 7.4. And I get 29.6. So the area for this triangle is 29.6. Again, miles times miles is miles squared. And there we go. Okay, number 3. We're asked to find the area of this trapezoid. Okay, so a trapezoid is a 4-sided shape where only 2 of the opposite sides are parallel to each other. Okay, so these guys are parallel. Okay, so let's remind ourselves the formula for finding the area of a trapezoid. We have the area of a trapezoid equals little base plus big base divided by 2 times by our height. Okay, so remember little base and big base, those are the 2 sides that are parallel to each other. Okay, so our little base would be the one that's smaller, so A would be 4 meters, and B, what's the other side that's parallel to it, would be 9.6 meters. And again, our height is easy to identify because it's the one with the dotted line. Okay, so now we can go ahead and plug all this into our formula. So we have area equals, and I'm going to put the top in parentheses, and I'm just going to leave the units off of it for now just to save some space. Okay, we have A, 4, plus B, 9.6. Okay, then we're going to divide that by 2 and multiply by the height, which is 4. Okay, well now we need to follow PEMDAS. Remember, the first thing always in the order of operations is parentheses, so we need to add 4 plus 9.6. Okay, so 4 plus 9.6 is going to turn into 13.6. Then we're going to divide that number by 2 and multiply it by 4. Okay, so then order of operations tells us, because we're both dividing and multiplying, and those guys are equals to each other, okay, we just solve it from left to right. Okay, so we'll divide first and then multiply. So I have 13.6 divided by 2 gives me 6.8. Okay, so now I have, I'm just going to turn this right here, 6.8 times 4. Okay, and this is going to be our last step. 6.8 times 4 is going to give me 27.2. So my final area for this trapezoid is 27.2. But remember, we need our units. It was meters. So whenever we're talking about area, it's our units squared. So meters squared. And there we go. Okay, let's look at number 4. So this guy is just a rectangle, 4-sided shape where they're parallel and they're not equal. Okay, so we have the area formula for a rectangle is length times width, or you can think of it as base times height. It's basically the same thing. Okay, so let's go ahead and identify our length. I'll just call 3.3 our length. That would mean 4 would be our width. Okay, so now I can just plug this into my formula. Area equals my length, 3.3 inches, times my width, 4 inches. Okay, I can go ahead and plug this into my calculator. 3.3 times 4 gives me 13.2. So I have my area for this guy is 13.2 inches times inches is where I get inches squared from. And there we go. Okay, so that was finding the area of the 4 basic shapes that we talked about. In numbers 5 and 6, we are asked to find the missing side of each triangle. Okay, well, we're given 2 right triangles. Well, whenever we're trying to find a missing side of a triangle, and we know 2 of the sides, we're trying to find the third, we need to use Pythagorean Theorem. Okay, and our Pythagorean Theorem is a squared plus b squared is equal to c squared. Okay, and now remember where we get a, b, and c from if I have a little right triangle. Okay, my a and my b make up the legs. Okay, and my c is always the hypotenuse. Remember, a and b can be switched. Doesn't matter which leg is a or b, but c always has to be the hypotenuse. That's the important one. Okay, so let's go ahead and look at number 5. Okay, so I'm going to go ahead and label these A, B, and C. Well, my hypotenuse I'm going to want to label first. That's across from my right angle. So I know X is my C. Doesn't matter which one's A and B. I'm just going to choose A is 6 and B is 8. Okay, so now that I know A, B, and C, we can just plug it into our Pythagorean theorem. We have A squared, so 6 squared, plus B squared, 8 squared, equals c squared. Okay, beautiful. Now I'm just going to start simplifying this because my whole goal is to figure out what c is. Okay, well, let's get rid of these squareds if we can. First one is 6 squared. Okay, we know what 6 squared is. 6 times 6 turns into 36. We also know what 8 squared, or 8 times 8 is. That turns into 64. And it all still equals c squared. Okay, now this is the part where some people get a little tripped up. They think they need to move these numbers over, when in reality, we almost have our c all by itself, but on this side we have 2 numbers. Well, let's just go ahead and combine those to make one number. It's telling us to add them. Okay, so 36 plus 64 is going to give me 100 on that side. and it all still equals c squared. Okay, well now to get c by itself, we just need to do the opposite of squaring something, which is to square root it. So I have c is equal to the square root of 100, or think what is the number that multiplies by itself to give us 100? That would be 10, because 10 times 10 is 100. So we know that that side is 10. Okay, and remember, when we have nice, pretty whole numbers on all three sides of our triangle, fun fact, it's called a Pythagorean triple. Beautiful. Alrighty, number 6, same thing. Let's identify A, B, and C. Well, I want to identify my C first. Okay, my C is X again. Okay, I'm just going to choose A as 3 and 4 as B. So now I can plug it into my Pythagorean theorem. So I have A squared, 3 squared, plus B squared, 4 squared, equals C squared is X squared. Oh, and notice on these guys, I actually used C as my variable when it was X was that side. Does not matter. You can use whatever letter technically you want. It's still a variable. Okay, this time I'm using X. Okay, so let's go ahead and simplify, get rid of these squareds where we can. Well, we know what 3 squared is. 3 times 3 is 9. We know what 4 squared is. 4 times 4 is 16. And it all still equals X squared. We can't square the X because we don't know what it is. Okay. So now, again, we don't need to move any of these numbers over because X is almost by itself. We just need to combine. So we need to add these two numbers together. Okay, so 9 plus 16 is going to give me 25. It still all equals X squared. Okay, and my last step, getting X by itself, opposite of squaring something is square root it. So I get X is all by itself, the square root of 25, or the number that multiplies by itself to give us 25, is 5. So we know that our missing side of that triangle was 5. Beautiful. Alrighty. Okay, well, both 5 and 6 were Pythagorean triples. All three sides were nice, pretty whole numbers, but that's not always going to be the case. Okay, so we're still trying to find the missing side of the triangle, but notice that they're kind of ugly sides and they might not end so pretty. That's okay. We still have to solve it the exact same way. Okay, so looking at number 7, I want to identify A, B, and C. Okay, well, my A, in fact, let's identify C first, hypotenuse. Again, my C is X. I'm just going to make A as root 226. Really ugly number, but I'll show you what we do with it in a second. And that would mean B would be 4. Okay, so let's go ahead and plug it in. So we have A squared, root 226. Remember, it's not 226. It's the root 226, so you can't forget that. So A squared plus B squared equals C squared. Okay, well, now we simplify. Well, this guy, remember, what is the opposite of square? Square root. Those guys can't exist together. Whenever you have a square root and a square together, they cancel each other out. You're just left with what's inside. So now it's just 226 plus 4 squared, or 4 times 4. So 16, and it all still equals X squared. Okay, well, same thing we've been doing. We don't need to move any of these numbers. We just need to combine them. So 226 plus 16 is going to give me 242 on that side. And it all still equals X squared. Okay, well, same thing. Opposite of square, to get my X by itself, we square root both sides. So I get x is equal to, now I don't know what the square root of 242 off the top of my head is. I don't think it's a perfect square. In fact, I know it's not a perfect square. So we're going to go to our calculator. Okay, in my calculator, you're going to click second. Then above the little x squared, there's a square root, 242. And we get this decimal. Okay, well, let's go ahead and just round it to the nearest tenth. That's our first spot, so we need to look behind it. This 5 is going to bump what's in front of it up to a 6. So this would be 15.6. Okay, now, on your test and on your assignment, if it's asking for a decimal, like if it tells you to round something, that's what your answer will look like, right? That's our decimal form. But if it says something like give the exact or radical version, then what it actually wants is the square root of 242. And you don't even have to punch it in your calculator. Okay, but both of these answers are technically correct. We solved for that missing side. It just wasn't a nice, pretty number. Okay, let's look at number 8. Okay, so we need to identify A, B, and C. We're still working on finding the missing side of a right triangle. Okay, so I'm going to identify my C first. C is 16 this time. I'm just going to choose A as X and B as 12. Okay, so now I can plug it in. So I have A squared. This time my A is X, so X squared plus B squared equals C squared. Okay, same thing. Let's get rid of these squares where we can. Well, X squared, we can't square because we don't know what it is. So that stays X squared. 12 squared, or 12 times 12, is 144. And then 16 squared, or 16 times 16, is 256. Okay. So we've been combining numbers on the other side, but now looking at our side with our x, we actually need to get rid of. We need to move this number so we can get x by itself. So I need to do the opposite of plus 144, which is to subtract 144 on both sides. So I get x squared is equal to 256 minus 144. It's going to give me 112. Okay, then my last step, opposite of squaring something, is square root it. So I get x is equal to, I don't know what the square root of 112 is, so let's go ahead and punch it into our calculator. Square root 112, 10.58, let's round it to the nearest tenth, so that's our first spot. This 8 behind the 5 is going to bump it up to a 6. So our decimal form of the answer is 10.6. Or if it wanted the radical or exact answer, it would be just the square root of 112. And there we go. Okay, so sometimes when solving for the missing side, you'll get a nice pretty answer. No decimals, no radicals. Sometimes you will get a decimal or a radical, and that's totally fine. Okay, so let's go to our next page. Alrighty, so we're talking about triangles, and we're trying to find the missing length indicated of these triangles. But notice they're not right triangles, so we're not using Pythagorean Theorem. We're actually going to use proportions. Okay, and when we say proportions, that really just means fractions. Okay? So you'll remember us doing this a little bit ago. Alrighty, so first thing I want to do is I kind of want to split these into two triangles. So I'm going to do this bigger one as my purple triangle, this smaller one as my green triangle. Okay, in order to solve, and I'm just going to call this question mark x. Okay, we don't know what that is. In order to solve for x, find that missing length, we need to set up a proportion, okay? So for my purple triangle, I'm gonna go right over left. Okay, so 14 over x, there's our fraction, is equal to, now I have to follow the same pattern for my green one. Right over left, 6 over 9. Okay, now there's a couple different ways we can do this. We talked about 2 ways. The first way is to cross multiply. Okay, so I'm going to take 6 times x, 14 times 9. Okay, so I get 6 times x is just 6x. 14 times 9 is 126. Okay, now notice I have a little equation that I can solve for x. Okay, so looking at my side with my x, there's only one thing I need to do to get it by itself, and that's the opposite of times by 6, which is to divide by 6. So I get x is equal to 126 divided by 6 is 21. So we found that that missing side or missing length of that triangle was 21. And there we go. Beautiful. Number 10. Okay, so again, I'm going to split this into 2 triangles. I'll do the top triangle as my purple triangle and the bottom triangle as my green triangle. Okay, now I need to set up the proportion following the same pattern on both triangles. So I'll go same thing, right over left. Okay, so for my purple, 5 over 15. Okay, equals, same pattern for my green triangle, right over left, we'll call that x again, 4 over x. All right, so now I can set up my proportion. Now, the first way we talked about was cross multiplying. You create an x, you cross multiply, and you solve. The other way we talked about was what I call the fish method. So we start at the number that's connected to your variable, so this would be 4. When you go across, you're going to multiply. Okay, so we have 4 times 15. 4 times 15, which is going to give me 60. And then once you go up, you're going to divide. 60 divided by 5 is going to give us our x. You see how it creates this little fish-looking drawing? So 60 divided by 5 is 12. And that is literally it. We follow that pattern, and we got x equals 12. Technically, we just did the exact same thing as we did over here. It's just written a little differently. Okay, but we found the missing side. Okay, so we multiplied 4 times 15. Then we divided by 5, which gave us our x. 4 times 15 was 60. 60 divided by 5 is 12. X equals 12. And there we go. So you can choose which way you like better. You can do cross multiply and just solve for x. Or you can do the fish way, follow the pattern, and that will give you your x. Alrighty. Numbers 11 and 12. We are asked to solve for x, which we have been doing nonstop this year. Okay, well, this is what we learned as the exterior angle theorem. Okay, the exterior angle theorem tells us, if I were to draw a little triangle right here, okay, and I made this side kind of extend out a little bit. Okay, this tells us if I have angles A and B, these are my interior angles, and that exterior angle on the technically the outside of the triangle is C. Well, this tells us that A plus B is equal to C. Not to be confused with A squared plus B squared equals C squared. We just know that those two angles added together have to equal C. That's what our exterior angle theorem states. Okay, so looking at 11, we're trying to solve for x, which is given in 2 of our angles, but we know that this angle plus this angle has to equal that angle. Okay, so we just set up an equation. So first angle, we have 13x minus 6 plus my other angle, 72, is equal to the exterior angle, 22x plus 3. Okay, now we can start solving for x, but I have x's on both sides of my equal sign, which means we need to move the smaller one. Remember, I like moving the smaller one because it keeps it a positive number. Okay, well, the smaller one out of 13 and 22 is 13. So I'm going to subtract 13x from both sides. Okay, 22 minus 13 is going to give me 9. So I have 9x plus 3 on that side. Then I'm just going to combine these two numbers, get it one number. Negative 6 plus 72, or think 72 minus 6, is 66. Okay, and that looks like a lot nicer equation that we're dealing with. Okay, so let's look at our side with our x. I need to get rid of the 3 first because it's farthest from my x. So I do the opposite, which is to subtract 3 from both sides. I get 63 equals 9x. Okay, and my last step for getting x by itself, I'm going to divide by the 9 on both sides. I'm going to write it over here. So that cancels out. I get x is equal to 63 divided by 9 is 7. So x equals 7. And there we go. Okay, so in number 12, same thing. We have these interior angles and our exterior angle. Well, we know that the interior angles added together equals the exterior angle. Okay, so let's set up our equation. I have 5x minus 5 is my first angle, plus 55, my next angle, is equal to the exterior angle, 8x plus 17. Okay, so we're trying to solve for x, but again, I have x's on both sides of my equal sign, so I need to move the smaller one. Well, the smaller one out of 5 and 8 is 5, so I'm going to subtract 5x from both sides. Okay, so I get 8x minus 5x is 3x plus 17 on that side. Okay, and then these guys I'm just going to combine. They're just two numbers. Negative 5 plus 55, or think 55 minus 5, is 50. Okay, and now I can solve for x. I can start getting rid of things. Okay, so looking at my side with my x, I need to get rid of the 17 first because it's farthest away. So we do the opposite. Subtract 17 from both sides. 50 minus 17 gives me 33 is equal to 3x. Okay, and my last step for getting x by itself, opposite of times by 3, is divide by 3. So I get x is equal to 33 divided by 3, 11. So x is equal to 11. Awesome. Alrighty. Numbers 13 and 14. You are asked to classify each triangle by its angles and sides. Okay, so remember, angles, we have 3 options. Okay, let's write down these 3 options. Really small. We have either a right angle, an acute angle where all 3 are less than 90, or an obtuse angle where one of them is more than 90. Right is where you see a 90 degree. Okay, and then for sides, so we'll label that as our angles. For sides, we have isosceles, where 2 sides are equal. We have equilateral, where all the sides are equal. Or we have scalene, where none of the sides are equal. Okay, so first let's classify number 13 by its angles. Okay, so I see 40, 100, and 40. I don't see a 90 degree, so I know it's not a right triangle. And 2 of them are less than 90, but one of them is more than 90. Because I see that 100 there, that tells me it's an obtuse triangle. Okay, well now let's look at the sides. So I have measures 5.8, 3.8, and 3.8. Okay, well 3.8 and 3.8 are the same measure. Okay, remember where two sides are equal? That's our isosceles. So this triangle would be classified as an obtuse isosceles triangle. Beautiful. Number 14. Okay, so let's look at the angles. So I have 60 degrees, 60 degrees, and 60 degrees. Okay, I don't see a 90 degree, so it's not a right triangle. And I don't see any of them that are greater than 90, and all three of them are less than 90. So this tells me it's an acute triangle. Now looking at my sides, I have 13, 13, and 13. Okay, well those are all three the same measure. And where all three of them are the same measure or equal, you think equilateral. So this triangle would be classified as an acute equilateral triangle. And that's it for classifying triangles. Alrighty, last two examples. We're asked to solve for x. We're dealing with circles now, so angles or central angles and arcs. Okay, assume that lines which appear to be diameters are actual diameters. Okay, so let's go ahead and just remind ourselves what a diameter is. Okay, so that's straight from one end of the circle to the other, which is equal to 180 degrees. Think of it like half of that circle. Alrighty, so we're trying to solve for x. Well, x is given right here in the measure of this arc right there. Okay, now it's giving me 57 and 81, and then I have two missing arc measures. Okay, well, the 81 doesn't really help me, but what do we see that it's creating? This arc plus the 57 creates half of our circle, which again is equal to 180 degrees. Okay, so if we add the red arc with the x that we're looking for, plus the 57, set it equal to 180, we can solve for x. Okay, so let's go ahead and do that. So I have 12x plus 15 plus 57, and it all equals 180. Okay, well now I can solve for x. I have x's on all one side. I just need to combine some like terms. 15 plus 57 I can combine. And that's going to give me 72. So I have 12x plus 72. Still all equals 180 because we haven't moved anything. Okay, so now I can look at my side with my x. I need to get rid of the 72 first. Okay, so I do the opposite. Subtract 72 from both sides. I get 12x is equal to 180 minus 72, which is 108. Okay, my last step to get x by itself is the opposite of times by 12, which is divide by 12. So 108 divided by 12 gives me x equals 9. And there we go. Awesome. Okay, we're doing the same thing for 16. Okay, we are still given our x right there. It's the measure of this little arc. Okay, well, one thing, because it's also giving me this 65, but then it's giving me this 75 as a central angle, but we know that the central angle is actually equal to the measure of the arc. So if that's 75 degrees, then we know the arc is also 75 degrees. Okay, and again, what do all three of these arcs create? Half of my circle, or that diameter, which is equal to 180 degrees. Okay, so let's go ahead and add all three of these arcs up, set it equal to 180 in order to find my x. So I have x plus 49, my first arc, plus 65, second arc, plus 75, third arc, and it all equals 180 degrees. Okay, so now before I solve for x, I need to combine some like terms. 49 plus 65 plus 75. I'm just going to plug that into my calculator. 49 plus 65 plus 75. And that gives me 189. So now I have x plus 189 equals 180. Okay, now there's only one step I have to do to get my x by itself. I just need to get rid of plus 189. So I do the opposite. Subtract 189. So I get x is equal to 180 minus 189 is negative 9. Okay, remember you can get a negative here because you would plug that in and then adding the 49 would make it positive. So you're totally fine to get a negative as your answer. So x equals negative 9. Okay, those are your review notes. There is an assignment that goes with it.